Hello, I'm Nicholas Moorhead, and I am on the EPIX project, Australia Solar Fuel, the carbon conversion side. Okay, so our team, it starts Abby Jansen is a senior chemical engineer, Mickey Lamansky is a senior chemical engineer, Zachary Hargis is a freshman chemical engineer. I'm Nicholas Moorhead, I'm a freshman mechanical engineer. Aaron Gobiel is a senior chemical engineer, and Aiden Huang is a freshman computer science major. Okay, our project foundation. Originally, this project started last semester, and it was meant to be a partnership with the University of New South Wales, and that never really came to fruition. And then with COVID, it completely fell apart. So right now we have kept the project going from last semester to this semester as a theoretical systems design. It was split into two teams to make it simpler for each side. So right now there's a solar team that meets every Monday, and we are the carbon team, carbon conversion. We meet every Tuesday, and right now we're focusing on designing a CO2 conversion to convert CO2 from the atmosphere into a usable carbon-based fuel. Our problem statement. Okay. The burning of fossil fuels has put CO2 emissions past the absorbance capacity of the Earth, and there is a need for innovative, sustainable energy sources. Our team is addressing the problem of efficiency using a large remote plot of open desert land for a sustainable system converting atmospheric CO2 to a usable fuel. And stakeholders. Right now, Joshua Lohman was the main person that worked with Abby to create this project. So I wouldn't say a main stakeholder, but he's the one that got it started, and he had the info and communications with the University of New South Wales. Uh, as of now, we're trying to look for businesses and consumers that would be interested in the end product that might help us along the way, or be interested once we have the project finished. We're looking into Lightworks, which is a organization at ASU that works on a fuel, like not fuel, but is working to prevent carbon in the atmosphere. Kirk Thompson is another uh, potential like community partner that we have, and he has worked with Lightworks before. And Klaus Lackner is a professor at ASU who created carbon trees, like artificial trees that can capture carbon from the atmosphere. And we have been in contact with him and are trying to work with him to further our project along. Where are we? As of right now, we're between specification development and conceptual design. We finally decided on a singular fuel, which is dimethyl ether. So now we're working on creating an actual system to convert CO2 into dimethyl ether. And then carbon neutral energy, the process of capturing carbon from the atmosphere to recycle it into fuel. This creates a net impact of zero on the atmosphere and reduces global CO2 emissions. And our main goal as of right now is to create a carbon neutral fuel that's a repeatable fuel source so we can continue making it with no downsides on the environment and to reduce global warming overall. As I said before, the artificial trees are what we are looking at intently to capture carbon. And Klaus Lackner at ASU prototyped them and has been using them. And right now they can remove about 100 tons per day of carbon, and they're very automated, so there's little like hands-on maintenance. Right now the tower lifespan is 10 to 20 years and the filters last several years. It does not come with a storage device, but there is a way with thermal reactors to get the CO2 out of them through using steam, and then it creates a highly dense CO2 solution that can be repurposed into pure CO2, and then we can use that to turn it into a fuel. On picking a fuel, we used a AHP chart, which had 9 different criteria that we considered for weighing: cost of fuel production, energy input, byproducts, efficiency of a fuel, market, storage, profitability, fuel cleanliness, and transportation costs. And using that model, we determined profitability and fuel cleanliness were the most important criteria. And this is the chart at the bottom of the screen. You can pause the video and look through it if you'd like more details. And then deciding on a fuel, in the week before the last design review, We had four options that were our main options looking into, and we narrowed it down to dimethyl ether using this chart. As you can see, it scored highest out of all the other fuels. And then our goal with captured carbon, our main goal is to convert it into a usable fuel that is carbon neutral. And dimethyl ether and methanol were the most like sought after options we were looking for. And dimethyl ether is a safe option due to the corrosive nature of methanol. And we have found prior conversion paths of CO2 to dimethyl ether that currently exist and have been tested and tried. And then whether this dimethyl ether is clean burning and non-toxic, has a high cetane number, and diesel alternative, or can be added to liquid propane gas. And then methanol is a biofuel alternative for gasoline vehicles, can be made out of natural gas and is less flammable than gasoline. And the main downside with methanol is that you can't actually create it straight from CO2. It's a byproduct of other like natural gases and uh, uh, like fracking byproduct. And as of right now, we're further looking into carbon capture, and we wanted to find the systems to use to create an actual system for carbon conversion. We're looking at initial reactants, catalyst needed, and a whole reactor setup. And as of right now, we need to work with the solar team to see how far they are along and the amount of power that we can feasibly get to create a system. Thank you, and that is all.